Hello. Um, in this video, we will be going over section 2.6. And in our 2.6, we're going to start looking at surfaces as an extension of our three-dimensional study. Um, and these surfaces are special types of surfaces. One type of surface is going to be called a cylinder. The other are going to be a set of quadric surfaces that kind of mimic our idea of conic sections in 2 dimensions, but we're going to be looking at these in 3 dimensions as surfaces. So let's get to our first objective. Okay, our first objective is going to be looking at cylinders. In the cylinders, we think, well, I know what a cylinder is. It's one of these guys that have a circular base that has a height, and so that's what we think of when we think of cylinders generally. But we're going to extend our definition of cylinders and take a look at them from kind of like a mathematical point of view and described by equations. So the formal definition, or at least a definition in the book, a cylinder is a surface that consists of all lines, called rulings, that are parallel to a given line and passes through a given plane curve. So let's imagine this cylinder, and let's put the cylinder into our three-dimensional space, x, y, and z. And these rulings that they're trying to describe are parallel lines parallel to the z-axis, and they run along and create this surface. Now, here they also talk about traces, and the trace is our definition of a trace that we'll see a little bit later on. That it's going to be like the intersection between the surface and one of the coordinate planes. And so we'll see the coordinate plane x, y, and then you could imagine the trace of that would be a bunch of circles. So generally, if we run along the rulings, these parallel lines, we're going to get kind of like the same shape, same two-dimensional shape that we're repeating along those rulings. Okay, generally, for me, I think about a cylinder. If I'm given an equation, I look at the equation and notice that one of the variables is missing. And so what I would do is I would take the other two variables, and on that coordinate plane, I would draw whatever two-dimensional shape is. So the two-dimensional shape will be a curve, and I will sweep it along the variable that's missing. And of course, since we are talking about cylinders, our first example is going to be this circular cylinder. And I'll describe it as a circular cylinder because we'll see why. Now, I imagine on the XY plane, if I just have an XY plane, I would look at this and imagine, oh, that's just a circle of radius 1. So what I want to do is I want to draw this in space with the x, y, and z axis, and I would draw that same circle, except the xy plane is down here, so I would draw this kind of from a perspective kind of space. And so this is exactly this circle being tilted down, so now it kind of looks like this. Now the idea about this is that in this equation I don't see a z variable, so along the z variable I would draw my rulings. That would be lines kind of like that. Now, I don't want to draw too many because it might kind of get a little too confusing, because it's hard to see what's in front and what's behind. But if we gather all that and look at the trace is going to be circles. So along the rulings, we're going to have these circles. Okay, so I think my perspective changed and the green traces, but that's generally how it's going to look like. Well, The other thing I like to do is I like to describe these surfaces using an adjective and a noun description. Um, so when I'm identifying the surface, I see the surface as a cylinder. So that's the noun part, right? So a little grammar lesson here. We have a noun, and then we're going to use an adjective to describe what the trace is that's going to go along the rulings. So the trace is a circle, and that's going to get swept up and down the missing variable axis, and so that's going to be the adjective. Okay, let's take a look at another example. And in this example, I'm looking at it and thinking z is equal to y squared. I don't see an x there, so the x is missing. So I would imagine the shape getting swept along the x-axis. I can first draw the yz plane. So let's draw the yz plane and isolate this. And this is a parabola going up along the z-axis. But since the x is missing, I want to call this a cylinder. So the noun again is a cylinder. And then the trace, the main curve is a parabola. So I would call it a parabolic cylinder. So this is your adjective. Okay. Now, if I were to draw this in 3D, I would have my x, y, z space, and then I would draw a parabola on the yz plane. So this is looking at it directly ahead, and so I would draw that as a regular parabola. If I was looking at it sideways, I might have it skewed a little bit. In any case, I would draw the rulings. The rulings would be running along the missing axis. So running along the y-axis, I would draw lines parallel to the y-axis up along the top and throughout this parabolic shape. And then each of those rulings will be running through the curve that is describing this parabola. So you can imagine a parabola up front, a parabola behind, and all kinds of other parabolas in the middle. Okay, so this is a cylinder because it's something that's being swept, but the shape is in the shape of a parabola, so it's a parabolic cylinder. Okay. Now, just to throw out another definition of things that we've been using already, a trace of a surface is a cross-section that intersects a plane that's parallel to one of the coordinate planes. So if we imagine the YZ plane here, the traces are going to be all this parabolas, and so that's why it's defined, or that's why it's called a parabolic cylinder. Okay, all right, good. Oh, let's take a quick peek at our graphs in CalcPlot 3D. We're continuing to graph implicit surfaces. So implicit surfaces, and here I have it already set up. The first one is this circular cylinder, and you can see the traces going up and down. Oh, I'm sorry, the rulings going up and down, and then the traces are circular. And then the other graph is our parabolic cylinder, where you see the shapes of these cylinders running along the axis. Okay, I hope that helps. Good luck.